Hey everyone, and welcome back. This is class number 2 in our Algebra 1A course. If you're watching this video, then maybe you were absent during class, or maybe just coming back to learn some more, which is wonderful. These videos are here to help support you throughout this school year and just help you keep up with what we are doing in class, especially if you are absent or you feel like you missed something. Let's get into it. So objectives for today, we're going to talk about different vocabulary words that come up in algebra. Super important to start at the ground and build up, and oftentimes just knowing what different words mean and what they are is a great place to start. So we're going to look at some vocabulary words first, then we'll talk about different types of numbers, and then we'll slide into order of operations and solving for variables. So a couple things we want to try and cover today. Our essential questions: what are the different types of numbers? Are all number types completely separate, or do they overlap in some way? And then what is the process of solving for a variable? Okay, so this is something that I did not get to yesterday that I did kind of want to touch on. When you are taking notes in math, and I do highly encourage you to take notes, this is what I would suggest you do. Whether this is a notebook or a loose leaf piece of paper, top of the page have the date and then the unit you are in, and give your class a title. And you can look at this video for inspiration as to what the title is today. It's going to be about Introduction to Algebra and Vocabulary. You can use the objectives to make up a title if you feel like there isn't one there. Write the objectives down. This kind of works almost like a table of contents for you when you're looking through your notes. You can see very quickly, here's the notes about, and the example you can see here, it's like Sokotos. This is from a geometry class, but for algebra today, it would be like, oh, here's the notes for vocabulary. And then you can go read down further through it if you're looking for something in particular, and it's just a great way to keep yourself organized. If you have a different organization system that works, and emphasis on works, great, keep doing that. If you don't have a system or you don't have something that works, maybe consider trying mine out. So I would have my objectives at the top and then my essential questions, which you saw displayed in the previous slide. Just write those down. And when you're taking notes, guys, it does not need to be word for word. That's kind of a really important thing to note, is that when you take notes for yourself, it should be abbreviated, shortened down. It's the key stuff that you feel like, you know what, this is new to me. I don't really know that. That's really important pieces of information, that sort of thing. So like for the essential questions, I would kind of pare them down a little bit. So like if the one example here is, how do I solve for a missing side of a right triangle when given a side and angle? I might shorten that to solve for missing side given angle inside with a question mark. I mean, we know we're in the triangles unit, so it's not like I need to put triangle down every single time. And then I would leave space for writing the answer in. So once you come across that part of the class where the essential question is answered, write the answer in there. Or wait until the end and then go back and see, can I answer those questions? Did I learn today what I was supposed to learn? Once you get into the note-taking part, it kind of comes down to what's going on in class. So if you see formulas, that should definitely be down there. Any shorthand stuff, write notes to yourself. So like the solve the triangle. So when I say that in geometry, that means go find the value of all the side lengths and angles. If you see the word in algebra like isolate, well, what does that mean? Solve for the variable, evaluate, expression, equation. Like if you don't know what those words mean, this is a great time to write those down and either go find a definition later or ask me in class, or if I'm just giving it to you in class, then write it down as well. And then have some examples in there if there's examples. And what I like to do with examples is write down the steps of what I'm doing. So you can see like in the kind of lighter gray, it's the sign stuff, and then I've written on the right, okay, I'm using SOH. I know this doesn't mean a lot to you guys since you're not geometry students, but I'm writing notes to myself about how I solve this particular problem. And that is a good set of notes. So when you go back to look at this again, you will be able to reteach yourself or learn some more from it. You can use these videos as a great source of information, but you should still be taking notes, and same thing in class, you should still be taking notes when you are experiencing the material so that you are telling your mind, hey, this is something important, you should start learning it. And by just writing, your mind is kind of like, okay, I should know this stuff. If you're just sitting and listening and being passive, your mind is kind of dismissing a lot of what it's hearing. All right, so pause the video if you need to. Set up a notebook that looks like this. So you've got 3 columns, vocabulary definition, and then a diagram example. And we're going to fill in the blanks for each of these words that we're going to see. So again, pause the video if you need to, and then continue on. So the first one that we're going to look at is an example of the word expression. So very different to what we think of when we think of expression for the English language and the appearance of your face. An expression in math is a math sentence that does not have an equal sign. So you see on the right-hand side there the example, 3x plus 2y minus 6. So there's no equal sign, there's nothing to solve, this is an expression. All right, so we're going to complete the table for each of the following words. So we did expression already, and now we want to finish it off with these words. So what is an equation? What's an inequality? A term, a numerical expression, an algebraic expression, a coefficient, a constant, a variable, an operator, and a numerator. Pause the video and go try and figure those out for yourself, or fill in the ones you think you already know, and then come back when you're ready to hear what they are. All right, so an equation, if an expression is a math sentence that does not contain an equal sign, an equation does. So there is going to be an equal sign in there. So math sentence, oh my gosh, I just misspelled sentence. So math sentence plus an equal sign. And then you could say like 2x plus 5 equals 10. There's my example. So you're filling that in for the whole way down. An inequality is when you have two expressions that are being compared to each other and one may or may not be bigger than the other. So we would have something like 3x plus 5 is less than 2x minus 11. And we would go solve that. So we could figure out, okay, one side is bigger than the other, so they are not equal. This is not an equation. Both sides of the inequality sign are not necessarily equal. Now they could be, especially if it's like a less than or equal to inequality, but they do not have to be. So you're writing out that sentence and then giving the example as well. So a term, parts of an expression that are separated by an operator or an operation. So it kind of comes down here to this word as well. So if we have something like 2 plus 3x, 2 is a term and 3x is a term, minus 21y, negative 21y is another term. So the parts of an expression separated by an operation or operator. Numerical expression, so we're seeing the word expression again, so math sentence with no equal sign. Numerical expression means it contains just numbers. An algebraic expression would be something like 2x minus 11 plus 5. It's got letters and numbers. So variables is the technical word for a letter, and then numbers as well. Coefficient, this is the number that comes before a variable. So when they're in the same term, so they're separated by, say, like two operations, the 4x is the term, the coefficient is the numerical part of a term. So if I was writing that out, I'd be like numerical or number part if there's no variable, there's no letter, then it's known as a constant. So 3 and negative 5 are the constants in that expression. So constant is a number with no variable, and a coefficient is a number that has a variable in the same term. A variable is a letter or symbol used to represent a value. Again, my spelling is on point today. And we might choose something like a, pi, x, a smiley face. Like, I mean, you can use any letter symbol to represent a missing value. It does not have to just be a letter. So like pi is from the Greek alphabet. That's not really a variable. It's actually a bad example because that is a technical value. So like when we start getting into higher levels of math, you might see like a beta or something like that being used. So pi actually has a value, so I don't want to confuse that. Operator, we've talked about this. This is your plus, minus, multiply, divide. Parentheses are kind of included in that. So it's the symbols in the equation or expression that help define the overall value. So technical words, the things that separate the terms. And then numerator is when we have a fraction, it's the top part of a fraction. Oh, I did have denominator in here too, sorry. And then bottom part. So you would have top part of a fraction, give an example, bottom part of a fraction, give an example. So you're filling in your table with each of those. That's a great table to just refer back to. Turn it into a poster and put it in your room or somewhere in your house. Like posters for me are a great way of reminding yourself of content, and it depends on you as the learner. For me as a learner, when I was in high school and even to this day, I love posters as a way to learn because I would look at it multiple times a day. I could visualize it in my head when I came to things like tests or quizzes. It was a great way for me to learn or to memorize stuff. So if that's you, maybe give it a shot. Make a poster of this when you're making your notes. So instead of doing it in your notebook paper, do it on a piece of poster paper instead, and write it out, make it look nice, put it up on the wall somewhere, and then just check on it a couple of days and see, do you know your stuff? The types of numbers, you might be a little confused as to what I'm talking about here. This is the way that we categorize and put different numbers into boxes based on their characteristics. So some of them share characteristics, some of them do not. So if we think of all numbers being the universal set, so this is every single number you can possibly think of. The first way we separate our numbers is real numbers and imaginary. And you might be like, imaginary numbers, what is that? This is something you will come across in Algebra 2 first. So we don't touch imaginary numbers in Algebra 1. They essentially are numbers that are not real, and we'll see what the criteria are for being a real number very soon. Within real numbers, you've got things like rational and irrational numbers. So rational, irrational. We've got integers, and then maybe we've got like just whole numbers. So natural numbers is the name of that set. There are other subsets we can do, but this is like a good place to start. Some other words that I want you to add in. So we've got the ones I just kind of threw up at you, and then some other ones as well. So real, imaginary, rational, irrational, prime, composite, square. I put real in there twice, I guess, and imaginary, so I'm going to cross those out. You don't need those. Odd, even, square, and triangular numbers. So a real number exists in the real world. So it's something you can see, feel, touch. Imaginary numbers, you cannot. So we see imaginary numbers popping up a lot in like things to do with like electricity and physics and a couple of other kind of abstract areas like that. All right, so then, yep, just finish that off, put those in your notes, look up your definitions, like rational, any number that can be written in the form a over b, so you can write as a fraction. Irrational, you can't. So like numbers like pi, square root of 2, e, they would all come under the irrational numbers. Prime numbers, these are numbers that are only divisible, so the only factors are itself and 1. So we'll talk about factoring a little bit more. But you'll find almost all of these definitions with a quick Google, and I don't really need you to necessarily understand them at the moment, but let's start looking them up and getting used to that idea. Especially if we come across a word that we don't know in class, how do we actually find out what it means? Composite number is anything that's not prime, so it's all the other numbers. A square number, so we think of this as something that can be represented as x to be squared. So if you think of something like 2 squared, you would get 4. So 4 is a square number. So it can be rewritten as a factor squared. So it has a factor that repeats. So a factor, I guess if we're going to go into extra words that maybe we want to think about, a factor is the numbers, and usually we're talking about whole numbers, by the way, whole numbers that multiply to be a larger number. So if I said something like, what are the factors of 12? We would say, okay, 1 times 12, 2 times 6, 3 times 4. So those are my factor pairs. Even and odd numbers. So what's an odd number? It's a number that cannot be divided evenly by 2. An even number can be. So like 3 is an example of an odd number. 6 is an example of an even number. Square number, I guess we just talked about that again. And triangular number, well, this is something that can be written, not squared. So triangular number is something where the numbers can be rewritten with like 3 equal sides. So for example, like 3, you would say, okay, that can be rewritten as 3 dots, so that would be a triangle. The next one would be 6, so you'd have 1, 1, 2, 1, 2, 3. Next one would be 10. So a square number, I guess another way to think about that is one where the dots can be rearranged in a square. So 4, 9, 16, and so on. Just another way to think about it. Okay, so here was our breakdown of numbers, so real, rational. So if we have rational, then irrational. So actually the way this was designed was imaginary numbers was out here. So you have real numbers, which is a much greater set, and then imaginary numbers, which is on the outside here. So it's not part of the real numbers. Again, poster worth making, and just kind of keeping somewhere on your wall or something like that, so you can kind of get an idea of like what are the breakdown of numbers. So an integer is a positive or negative whole number. A natural number is just a positive number. Prime numbers, composite, we talked about that. Those are subsets of the natural numbers, but either divisible by itself in 1 or not. Rational numbers rewritten as a over b. Irrational numbers, pi, root 2, root 3, e. So like these irrational numbers that we see. And then imaginary numbers, something like 2i. So there's a little I after an imaginary number. Square root of negative 2. So like square root of a negative number would also be imaginary. Moving gears, so like in class at this point we might like go through some other examples, stuff like that. There is a Quizlet as well that I would like you to take a look at. But if we're talking about just this video and what we're doing, we're skipping next into order of operations. So order of operations, we're trying to think about if we are evaluating. So to evaluate is to figure out what the value of something would be. So sometimes you'll see like these brain teasers. It's like 2 plus 3 minus 5 all to be squared divided by 7, and it's like evaluate this. What's the answer? And usually it's like there's a question mark about what the order of operations would be. But it's just like everything you need is given to you, and you're being asked to get what is that final answer. So actually go solve it. We use order of operations to help us with that. So that just tells you what you do first. So like parentheses comes first, then exponents, then multiplication or division, then addition or subtraction. And there is a order of operations poster in my room. You can just remake this very quickly for yourself as well. So you've got the order in which you do it. So first parentheses, second exponents, multiplication or division. It doesn't matter which one you do first, but they come next, and then same thing with addition, subtraction. So shorthand PEMDAS. So if you need help remembering PEMDAS, the mnemonic that you can use is please excuse my dear Aunt Sally. So that just kind of is like a, oh, PEMDAS, got it. All right, let's take a look at a couple of examples. So in this one, we've got 3 times 4 plus 1. So 3 times 4 being 12, plus 1, we've got 13. So just thinking about it, we've got PEMDAS. So the question would be like, do we do 4 plus 1 first, or do we do 3 times 4 first? So looking at it, parentheses, there's none. Exponents, there's none. Multiplication, division, yes. So multiplication, division comes first, so that would be 12 plus 1. Answer 13. Next one, we've got 6 minus 1 times 4 divided by 2. First thing, parentheses, yes. So 6 minus 1 is 5. So we can now drop the parentheses. So now it's 5 times 4 divided by 2. No exponents, but we do have multiplication division. If you have both, so there's multiplication and division, you do it from left to right. So 5 times 4 is 20. And then 20 divided by 2 is 10. Now, it wouldn't have mattered if you did 4 divided by 2 first. You would have gotten 2, and 5 times 2 is also 10. But in general, go left to right if you're at the same level on PEMDAS. All right, your turn to take a shot. Try the questions, pause the video, and see if you can solve it, then come back to see the answers. All right, welcome back. So 5 times 10 minus 4, thinking about, again, PEMDAS. Parentheses first, 10 minus 4 is 6, so it would be 5 times 6, which is 30. Then we've got 3 times 10 minus 5 divided by 5. PEMDAS, there's no parentheses, there's no exponents, but there is multiplication division. So 3 times 10 is 30. Minus 5 divided by 5 is minus 1. So it would be 30 minus 1 is 29. So that one can catch some people out. It's not 30 minus 5 is 25, divided by 5 is 5. So if you got 5 as an answer, your order of operations was off. You needed to do the minus 5 divided by 5, which is negative 1. So it would be 30 minus 1. And then the last one, if you have a fraction, you can consider the numerator and the denominator to be in their own parenthesis. So you would sort those things out first before you would think about getting rid of the fraction. So 3 minus 11 is negative 8. So you got 4 minus 2 times 6. And if you're inside of a parentheses, you start over again. So inside the parentheses, we've got 4 minus 2 times 6. The multiplication division comes first. So this would be 4 minus 12. And 4 minus 12 is also negative 8. So negative 8 over negative 8 plus 16 divided by 4. A fraction, remember, is the same as negative 8 divided by negative 8. So a fraction is division. So these would come first. Negative 8 divided by negative 8 is positive 1. Anything divided by itself is 1. And 16 divided by 4 is 4. So 1 plus 4, the final answer is 5. How did you do? If you're not quite getting that, that's totally okay. Maybe go back, try them again from start to finish, show all your work, and then we will have some opportunities to practice coming up as well. So this one is kind of like an algebra problem. I mean, it is an algebra problem, but shown in a different way. So you've got a cat plus a cat plus a cat is 30. A pig plus a pig minus a cat is 22. A pig minus a horse is 11. What is a cat plus a pig plus a horse? And you need to try and solve that, so we need to figure that out. So this is essentially an algebra problem where we've got some placeholder values going on in here. So if a cat plus a cat plus a cat is 30, that means 3 cats equals 30. So 1 cat must be 10. So cat is 10. And you can pause the video and solve the rest of these on your own if you'd like. So a pig plus a pig minus a cat, so that means 2 pigs minus 1 cat equals 22. We know the cat is 10, so 2 pigs minus 10 equals 22. So we would add 10 to both sides. 2 pigs equals 32. And then, so the reason I added 10 to both sides is I'm trying to get pigs on its own. So I'm trying to isolate the variable, which in this case is pigs. If we're subtracting 10, the opposite of that, so the way to negate it is to add 10. And if it's an equation, you have to do the same thing to both sides. So by adding 10 to both sides, I get to nullify that. And that means 22 plus 10 is 32. So 2 pigs has a value of 32. To get 1 pig on its own, I would divide both sides by 2. And I would get 1 pig is 16. So pig is 16, cat is 10. Then going down to the third one, 1 pig minus 1 horse equals 11. 1 pig we found out is 16, so pig 16 minus 1 horse equals 11. 16 minus 1 horse is 11, so we would subtract 16 from both sides to get the horse on its own. So minus 1 horse is equal to minus 5. We want a positive horse because we want to know what the value is of actually of 1 horse, so we would divide or multiply by minus 1 on both sides. So they cancel out and we get 1 horse, a positive horse, is equal to, the negatives also cancel here. So 1 horse is equal to 5. So then cat plus pig plus horse, we sub those in. Cat is 10, pig is 16, and horse is 5. So 10 plus 16 plus 5 is 26, plus 5 is 31. So that will be our final answer. Now guys, this is an algebra problem. This is algebra. You have variables and you are trying to solve for those missing variables. Let's do another one. Apple is 7. Grapes equals 5 plus apple. Apple equals 1 plus banana, and it's a bunch of bananas. Apple plus grapes plus 1 banana equals blank. So what we have to realize here is that there are 3 bananas in this bunch. So pause the video, try and solve it. So apple is 7, that one's given to us. So we'll say apple equals 7. Grapes equals 5 plus an apple, which is 7. So grapes are 12. And then apple, which is 7, equals 1 plus 3 bananas. So it's not 1 banana, it's 3 bananas. So then we want to get bananas on its own. We have to use our order of operations and subtract 1. So it's reverse PEMDAS when we are solving. So evaluating is PEMDAS. Reverse PEMDAS is for when we solve, when there's a variable. So evaluate and solve. So when we're trying to get our variable on its own, we do any addition, subtraction first, then multiplication, division, then exponents, then parentheses. So addition, subtraction, the 1 is being added to the 3 bananas. 3 has some multiplication going on, so we get rid of the 1 first. 6 equals 3 bananas. Then we're up to multiplication, division. So it's 3 times bananas. We're going to divide by 3 on both sides. We get 2 is equal to 1 banana. So then apple plus grape plus banana, 7 plus 12 plus 2 is 19 is 21. So 21 will be your answer here. Okay, this time, apple plus apple plus apple is 30. Apple plus banana bunch is 18. Banana bunch minus 2 coconuts equals 2. And coconut plus apple plus banana bunch equals question mark. And thing to note, there are 3 bananas in this one. There are 4 in this one. So just keep an eye out on that. All right, pause the video, try and solve it for the value of apples, bananas, and coconuts, and then also what is that final answer. Okay, so 3 apples. So 3 apples equals 30. 1 apple would be divide both sides by 3. So apple is 10. Apple plus 4 bananas plus 4 bananas. So that would be a total of 8 bananas. So 1 apple plus 8 bananas equals 18. So the apple is 10. So we can subtract that 10 from both sides to get the bananas left. So 8 bananas equals 8. That's a very easy one. Therefore, banana must be 1. So then we've got 4 bananas minus 2 coconuts equals 2. Banana is 1, so this is 4 minus 2 coconuts equals 2. Subtract 4 from both sides. Minus 2 coconuts, I'm just going to abbreviate as cocoa to keep space, equals minus 2. We would divide both sides by minus 2 because we want to get coconuts on its own. We want to get rid of that negative. So coconut is equal to positive 1. So coconuts and bananas are both 1. Then we go down to the bottom here. 1 coconut, so it's 1 plus 1 apple plus 3 bananas is 1 plus 10 plus 3 is 14. How did you guys do? This is the same problem. So instead of apples, we use A's. Instead of bananas, B's. Instead of coconuts, C's. And then we would go down and solve it that way. So you would get the exact same answer, but this time you were solving for the value of A, B, and C. So this is why I said it's all algebra, guys. It's the same thing. We like using letters because it's tidier to represent things than drawing pictures all the time. But you could just as easily use pictures. All right, let's take a look at a couple of practice questions. So the first one, 4x plus 3 equals 11. We need to isolate that x variable. To do that, we need to get rid of the 3 and the 4. So remember, isolate, we want to end up with a scenario of variable equals blank, and that's how we solve it. So for this, we need reverse PEMDAS. Or SADMEP, as I like to think of it in my head when I'm writing this out. So we do any addition, subtraction first, then division, multiplication, then exponents, then parentheses. So in here we've got 4 times x, so there's multiplication going on, and then plus 3. And we're trying to think again, how is it being applied to x? So 3 is being added to it, so it means the first thing we're going to do is subtract 3 from both sides. So that will leave me with 4x is equal to 11 minus 3, which is 8. Next up, multiplication division. We want to get x on its own. It's multiplied by 4. The way to undo that, or the inverse of that, if we're using correct math words, is to divide by 4. And what you do to the left, you must also do to the right to keep the equation balanced. So divide both sides by 4. x equals 8 divided by 4. 8 divided by 4 is 2. And then we've got minus 2n plus 10 equals 5n minus 18. So we want to get the n's on their own. So we're going to say we need the n's to all go to one side. So we have variables on both sides of the equation. We need them together. Usually what I try and do is think about, okay, if I want to bring 2n over to the other side, I would add 2n to both sides, and that will give me a positive number. If I bring 5n over, it would become negative. So I would have a negative n value. It's not a bad thing. It's just one extra step we need to do. So instead, I want to try and keep positive numbers going on. So I'm going to bring 2n over to the other side by adding it to both sides. So we're adding 2n to both sides of the equation to keep it balanced, but on the left-hand side, 2n minus 2n cancels because it's equal to 0. Same thing with the numbers. We want the numbers all on one side. If we're bringing the n's to the right side of the equation, the numbers need to go on the left. So to get rid of minus 18, we would add 18 to both sides. 10 plus 18 is 28. 5n plus 2n is 7n. So 7n is equal to 28. You can switch the sides, or I know I just switched them there without giving any reason for doing that. You can do that, or you can leave it as is. It doesn't matter. So you can switch the sides of the equals as long as the whole thing switches. It's 7 times n. So to get one n on its own, we would have to divide by 7 on both sides. So it's multiply, the opposite of that is dividing. So divide both sides by 7. You would get n equals 28 over 7, which is 4. So 4 is our answer here. And then turning our attention to the last one, we've got 2/3 times x, which is the same as thinking of it as 2 times x and then dividing everything by 3. So like you can think of it that way, whatever way kind of makes sense in your head. That's what 2/3 x means. So it's 2/3 times x. Plus 7 equals negative 7. Addition subtraction would go first, so we would subtract 7 from both sides. 2/3 x is equal to negative 14. So then to get x on its own, we're multiplying by the numerator, so remember from our vocabulary, numerator, and we're dividing by the denominator. So to undo that or to get rid of it, we would need to divide by 2 and multiply by 3. This is also called the inverse of a fraction or the reciprocal. So we're flipping it over. So 3 divided by 3 cancels out to be 1. 2 divided by 2 cancels out to be 1. But we must also do the same thing on the other side. So then x is equal to negative 14 times 3 over 2. And you can put it in parentheses or you can put a multiplication sign. It does not matter to me. Negative 14 divided by 2. So 14 divided by 2, I know that's 7. That's a little easier than doing 14 times 3 and then dividing it by 2. So 14 divided by 2 is negative 7. So it would be negative 7 times 3, which would be negative 21. So negative 21 is my final answer here. Let's try some on your own. All right, take a shot at these and see how you do. So we have minus 10 equals negative 5 plus x. N over 6 equals 30. X over 5 minus 7 equals minus 3. Pause the video, try them out, and then come back and see how you did. All right, so we've got x we need to get on its own. Let's get SADMEP up here for solving. So addition, subtraction first. We're going to add 5 to both sides. So that'll be minus 5 is equal to x. So x is equal to negative 5. N over 6 equals 30. So that means n divided by 6 is 30. The way to get rid of that is to multiply by 6 on both sides. So we're going to do times 6 times 6. So they would cancel. So n equals 30 times 6, which n is 180. Third one, x over 5 minus 7 equals -3. We want to do our addition subtraction first, so let's add 7 to both sides. We get x over 5 is equal to -3 plus 7 is the same as 7 minus 3, so that's 4. And then this looks like the one on the previous line, so we're going to multiply by 5 on both sides to get rid of that divided by 5. So we get x is equal to 5 times 4, which is 20. So when you're doing these questions on your own, make sure you're showing your work. So what did you do? So like adding 5 to both sides. You can write it in lines. You could say this is minus 10. So minus 10 plus 5 is equal to minus 5 plus 5 plus x. So you can just show that I added 5 into both sides and then cancel it down. I don't mind if you write the number underneath. Some people do. I'm not one of them. If that makes sense in your head, you are good to do that. All right, so our essential questions for today: what are the different types of numbers? Are all number types completely separate from one another? And what is the process for solving for a variable? So the first one, what are the different types of numbers? We've got real and imaginary. Within the real numbers, we've got rational and irrational. Within the rational numbers, we've got integers, natural numbers. We've got prime numbers, composite numbers, square numbers. Like there's a whole bunch going on in there. Are all the number types completely separate? No. Real and imaginary is kind of the first big divide, and then you've got rational and irrational. So like there are subdivisions in there, and as we get more specific, there are less numbers in that set. What is the process of solving for a variable? So evaluating, we use PEMDAS. Solving, we use reverse PEMDAS. So we do any addition, subtraction first, then some multiplication, division, then the exponent, then the parentheses. And I'm going to have some order of operations practice for you guys to do in class right after this. So you'll be doing that. Look in Schoology and see if you can find that worksheet and complete it now as well. Talk to you all soon.